So hi students, so this is the last lecture on chapter solution and conjugative property, and we are going to the numerical part, and this is the last numerical based on osmotic pressure. Now question is, what is the molar mass of solid? What is the molar mass of solid if a solution prepared by dissolving 0.822 gram of it in 300 ml of water has an osmotic pressure of 149 mmHg at 298 Kelvin. Okay. So here question asks, what is the molar mass of solid? Means M2 we have to find out. Yes. And this solution is prepared by dissolving 0.822 gram of solid in a volume 300 ml. Has an osmotic pressure 149 mmHg. At temperature 298 Kelvin, and here R value which are going to use is 0.08205 dm cube atmosphere per Kelvin per mole. Okay. Now here some conversion we will use, because R value we are going to use in dm cube. So volume will be converted into the dm cube, which is 0.3 dm cube. Okay. And here we require osmotic pressure is given here mmHg, and R value is given in atmosphere. So what we will do, 149 mmHg divided by 760 mmHg per atmosphere. So after calculating this, we get the answer, which is, I am writing here, 0.196 atmosphere. Okay. So here the pi value we going to substitute is 0.196 atmosphere. So formula is M2 is equal to W2RT upon pi V. Okay. So W2 is 0.822 gram into R 0.08205 dm cube atmosphere per Kelvin per mole into T 298 Kelvin upon pi, yes, 0.196 atmosphere, volume is 0.3 dm cube. Okay, so this is the substitution. Now definitely we have to find out the M2, and M2 means molar mass of solid, which has the unit gram per mole or kilogram per mole. Okay. Now what are the units going to cancel here? dm cube will cancel, dm cube will cancel, per Kelvin, Kelvin will cancel, atmosphere will be cancelled. Now what is remaining? Gram, and here per mole. So after calculating this, we get the answer, which is 342 gram per mole. Okay. So this is numerical based on the osmotic pressure. So here in any question, sometime it is asked find out the osmotic pressure, all the value will be given. Sometime it is asked to find out the molar mass of the solid. Okay. So last numerical. This numerical is based on vantoff factor. Now question is, 0.01 molar aqueous formic acid solution freeze at minus 0.021 degree Celsius. Calculate its degree of dissociation, means alpha we have to find out. Okay, and Kf is given here. Kf given 1.86 Kelvin kilogram per mole. Okay, now what is given in the numerical? Means formic acid, okay, and water. So water has freezing point which is 0 degree Celsius. When this formic acid is added into the water, this forms a solution, and the solution which is formed, this solution freeze at minus 0.021 degree Celsius. Means water has the freezing point 0 degree Celsius. When we added the formic acid into the water, it forms a solution, and that solution freeze at minus 0.021 degree Celsius. So I can say that this is TB, TF 0, and this is TF. Okay. So here formula which are going to use, first formula, that is delta TF is equal to R into Kf into M, because this is a modified formula for the depression freezing point. Okay, we have to find out the I, that is called as a vantoff factor. So first we will find out the I from here, and second formula is, we already studied, alpha is equal to I minus 1 upon N minus 1. So with the help of this formula, we can find out the alpha, that is degree of dissociation. So how to calculate it? Please here. So first we have to find out I. So formula delta TF is equal to I into Kf into N. Okay. So first we will find out delta TF. Delta TF is equal to delta TF 0 degree Celsius, means TF, formula we are going to use TF 0 minus TF. So 0 degree Celsius minus 0.021 degree Celsius. So answer will be yes, 0.021 degree Celsius. So we get the delta TF value. Now we have to find out the I. So I is equal to yes, delta TF upon Kf into M. Yes, substitute the value 0.021 degree Celsius upon Kf 1.86 Kelvin kilogram per mole into M. M is given here, which is 0.01, which can be molar. Molar means mole per kg. Okay, molar. N means mole per kg. So what happened here? Kelvin, sorry, kilogram will cancel, mole per mole will be cancelled here. Yes. So I is equal to, after calculating this, I will get here 1.13. Okay, we getting here 1 degree Celsius and Kelvin will be cancelled. Okay, so 1.13 I will get in here. Now we find out the alpha. Alpha is equal to I minus 1 upon N minus 1. Now here N value will be 2. Okay, N value will be 2. So alpha is equal to I value 1.13 minus 1. So alpha getting here 13%. Okay.